All right, let's take a look at example 4. Example 4 is a little bit different because instead of us giving just the function and us having to figure out what the real zeros are from the graph, they actually give you two factors. And we know that the factors are going to give you zeros of whatever the opposite signs are. That's what we're going to put into the synthetic division. So we're going to use the opposites of these. So that's going to be -1 and -2. Just to kind of get a comparison of how that is the same as before, is, if I were to graph this function here in Desmos, and if you look at, let me zoom in a little bit. If you look at where it crosses, there we go. It hits the point -2 and -1 on the x-axis. Well, that's the same as from here. Just switch the signs and you got those numbers. In this problem though, since they already gave you those two factors, we didn't have to put that in the graph. We just had to flip the signs and do our synthetic division. So that's really the only difference. It's actually less work if you think about it. We don't have to type that in the calculator. So we can go right ahead and say our real zeros are -1 and -2. And using synthetic division, doing it again with the -2. And of course, these are your remainders. So this is going to be x squared plus 0x, which doesn't have a term, x squared plus 8 equals 0, which we can totally solve that for x, so just by subtracting. So x squared is going to equal -8. And we'll do a plus or minus square root of that. Now we can't readily square root 8. We can break it down, but if I'm just taking that negative out, it's going to be x equals plus or minus I square root of 8. And I'm okay with that being your solution. So those are your complex zeros. Now, some of you might want to be able to break that down. So I'm not requiring it for these, but if you were to break that down, you would basically take that 8 and think about what goes into 8. Well, I know 2 and 4 go into 8, and I can square root 4, so that's actually going to be 2 times the square root of 2. So what I'm going to pull out with the I, if I'm reducing that, it's going to be plus or minus 2i, and then the square root of 2 will stay put. So either one of those is acceptable. I'll go ahead and circle the one before I reduced. So you can see those are both, they represent the same set of solutions. And again, that's fourth power, 1, 2, 3, 4 solutions, since the plus and minus count as 2. Try your turn and see if you're able to come up with all the solutions for that. So pause the video and try it on your own. Okay, this one was a little bit quicker. We only had one real zero since it only had one factor. So that's going to be -3. Again, it's the opposite of that sign. So switch the sign. That's your real zero. Let's use synthetic division. Pull out the 1, 3, 25, and 75 from the polynomial. Bring down the 1. Multiply by -3. Add down. You get 0. Multiply by -3, and you get 0 again. Add down. Multiply. Add down. Remainder is 0. So this is 1x squared plus 25 equals 0. Take away the 25. You can square root 25, so that's going to be a plus or minus square root of -25, since that's a minus. And remember, when it's a negative, you're going to have an I. So the square root of 25 is 5, and if it's a negative, 5i. And don't forget your plus or minus. Those are your complex solutions. So once again, that's going to be 1, 2, 3 solutions, third power. All right, hopefully that was helpful. Make sure you do the Unit 3 Day 4 assignment. That's going to be due in class tomorrow. If you have any questions, let me know.